Hello and welcome. Why did Beethoven get rid of all his chickens? Because all they ever talked about was Bach, Bach, Bach. And all we're going to talk about today is section 7.8, improper integrals. So let's get started. In the past, we've always dealt with areas under curves over a finite interval. In other words, an interval from a to b, where a and b are finite numbers. So for example, the integral under the curve from 1 to 3, and that computed the net area. In this section, we're going to explore an infinite interval, an interval that has an infinite length. So for example, the integral of the integral from 1 to the infinity of 1 over x squared. So that's what this picture is showing in figure 1, the integral from 1 to infinity of 1 over x squared. Now it may seem crazy to talk about the area under a curve over an infinite interval, but we're going to try it out anyway. But how can we do this? I mean, we can't just plug in infinity. That's not really a number. So when we go to plug in our limits of integration, how do we deal with the infinity? Well, just like we dealt with infinity in the past, we did it with limits. So what we're going to do is we're going to, instead of having infinity for the right side of our interval, we're going to make it t, like is in figure 2. So we're going to look at the integral from 1 to t, which is a finite interval, and find the area under the curve under that interval, and then take the limit as t approaches infinity, essentially moving that right side of the interval to the right, so letting t go to infinity. Actually, let me draw it down here. Letting t go to infinity. So these are called improper integrals. Whenever you have an infinity in either the upper limit or the lower limit of integration, so either on the left side of your interval or the right side of your interval, that's called an improper integral, and those integrals will be type 1 improper integrals, ones that have infinities in the limits. So there are 3 possibilities for a type 1 improper integral. One is where you have the lower limit is a finite number and the upper limit is an infinity. And the way you would write as a first step what that is it's the limit of the integral from a to t of f of x dx as t goes to infinity. So it's the limit as t goes to infinity of this integral from a to t of f of x dx. Now the other possibility would be, or another possibility would be if you have negative infinity for the lower limit of integration. So the right side of your interval is negative infinity, and the upper limit is some finite number, just calling it b here. So in that case, you would replace the negative infinity with a t, and then take the limit as t approaches negative infinity. This is always going to be the first step that you'll take in these 2 cases. Now the third case that we're going to take a look at is from negative infinity to infinity. So this is the area under the curve, under the whole curve from negative infinity to infinity. And for that, what we'll do is we'll split the interval up into 2 intervals, one on the left side and one on the right side. So from negative infinity to c, where c is just some number, some finite number that we picked. Could be 0, most of the time we'll use that for convenience, but it could also be like 2 or 10 or negative 15. And then you'll take the limit, the integral from negative infinity to c of f of x dx plus the integral from c to infinity of f of x dx. So that'll get both the left side and the right side. So in each case above, if the limit is finite, we would say that the improper integral converges. And it will converge to whatever we end up getting as a number in the end. After we rewrite it as a limit and we evaluate the integral and then take the limit, whatever that number that we get is what it'll converge to. But if that limit does not exist for whatever reason, so if it's infinity or negative infinity or doesn't exist because it oscillates, the improper integral, we would say, diverges. So let's look at example 1, where we're asked, does the integral from 1 to infinity of 1 over x dx converge or diverge? And figure 3 shows a picture of 1 over x. Looks very similar to 1 over x squared, you might notice. But we'll take a look at each of them. Let's focus on 1 over x first, though. So we're finding the area under the 1 over x curve from 1 to infinity. So let's see. Let's write that up. So this is the integral from 1 to infinity. I'm going to highlight the infinity in red because we're going to replace it in just a moment, of 1 over x dx. Now again, the first step in these improper integral problems is to replace the infinity with a letter, like we're going to use t, and then take the limit as t approaches infinity. So we'll have the limit as t approaches infinity of the integral from 1 to t of 1 over x dx. This step that we're taking is just the definition of what it means to have an improper integral. What does that improper integral mean? It means, or is equal to, the limit as t approaches infinity of the integral from, in this case, 1 to t of 1 over x dx. So that first step is just by the definition of an improper integral. And now we can evaluate that, or figure out what that integral is, and take the limit as t approaches infinity of what we get. So we still have this limit as t approaches infinity as an unprocessed action, but now we're going to integrate 1 over x, which gives you ln, absolute value of x, from 1 to t. We'll finish this part off. We're going to plug in t equals, plug in t, put a minus, plug in 1. So at this point we've got the limit as t approaches infinity of ln absolute value of t minus ln absolute value of 1. ln absolute value of 1 will become 0. And then when we take the limit as t approaches infinity of ln absolute value of t, well, as t gets large, ln of t is going to get very large as well. The absolute value bars don't do anything when t is approaching positive infinity because those are positive numbers. So we can drop the absolute value bars. And then again, though, as t approaches infinity, ln of t will approach infinity. So in this case, we would say that the improper integral diverges because we got infinity and not a finite number. So again, if the limit does not exist, and you know what I'll put up here is, if the limit does not exist, which includes plus or minus infinity, then we would say that the improper integral diverges. In a sense, what we're saying is that there's an infinite amount of area underneath the 1 over x curve from 1 to infinity. All right. So in the next video, we're going to explore an integral from negative infinity to infinity. So thank you for watching this part, and see you in the next part.